All right. Hello, everybody. Welcome back to Comp 2450. I hope that you have all had an excellent long weekend. I don't know about you, but it was much needed. I think, yeah, it was all much needed for you as well. I believe that we established that last week. I hope you all had a great long weekend. But I don't know about you, but I wish it was 5 days longer than it was. Yeah. Over the next 2 weeks, we're going to be talking about input validation and error handling. In our schedule on the course webpage, we've kind of got this broken up into 2 different parts. But when I was talking with Dr. Patrick about the organization of this, come to you in just a second. When we were talking about the organization of this, it kind of makes more sense to do it like as one big glob of errors and input validation kind of across 2 weeks, as opposed to trying to separate it into 2 different things. So over the next couple of weeks, what we're going to be doing is spending some time taking a look at errors and input validation. And in today's class, what I really want to focus on is I want you to be able to, at this point, identify different strategies for error handling, including exceptions, return values, and global states. In Java, we use exceptions. In Java, we use exceptions, but I want you to be able to know and identify that there are other kinds of strategies for doing error handling in different programming languages and different environments. Today, what I want to do with having you identify these different strategies for error handling is I actually want to take a look at a couple of different programming languages that do different things for errors and error handling out of necessity, because they don't have necessarily the same kinds of structures that we have in Java for this. I want to be clear, though, with the examples that I'm going to be showing you today. I in no way expect you to learn C for this course, but I will be showing you C code today to drive a point. I am in no way expecting you to learn Go for this course, but I'm going to show you some Go code because it drives a point. I am in no way expecting you to learn Python for this course, but I'm going to show you some Python code because it drives the point that I'm trying to make here. The code that I'm going to show you is completely understandable. This is really like basic stuff. All cases are going to do file management. They're all going to have the same kind of pattern, and we're all going to be looking at the same sort of things across each of these. I will be working in my terminal the whole time. I'm not using IntelliJ for this. Please don't let that scare you off. But all the examples that I've got for today's class are up on GitLab. I put a link to the repository under today's lecture notes. So you can follow along if you want, and if you have access to a Linux system. So if you want to do this, you may need to log into Aviary, but that's outside the scope of this course, and we're not going to talk about that. Yes, thank you for your patience.
I just want to clarify, is there going to be a quiz this week on Friday?
So there will not be a quiz this week on Friday, no. So here, yeah. So no, there will not be a quiz this week on Friday. Just because of the holiday. Same thing with the other section. They did not have a quiz 2 weeks ago because there was a holiday on Tuesday. We're not going to have a quiz this week because there was a holiday on Monday. Next week, we will return back to regularly scheduled programming. And then in that sense, I do want to point this out to you. The stuff that we're covering this week is still eligible to be assessed later. So like you can expect to see this on the final exam. You can expect to possibly see this on the quiz that we do next week, possibly. Yeah. All right. Okay, so first things first, I promised last week that I would give you some time to ask me questions about the project. I'm going to put 10 minutes on my timer. If there are more questions than I can get through in 10 minutes, I would invite you to please post those questions up on the course discussion forum. Come and see me during my office hours or send me an email. But I do want to constrain this to 10 minutes just to make sure that we're not all bored to death having me answer questions about the project. But I want to give you this chance to ask these questions. So I'm going to set 10 minutes on my timer here. And I'm not going to start it quite yet, but I'll hold this up for about 5 more seconds to give you a chance to get connected. And then I'm going to switch over to Mentimeter. Okay, awesome. So I'm going to switch over to Mentimeter here. And I have a question for you to start. This is something that when I was commuting by car in the winter last year, I saw on my drive to work on a regular basis. I'm going to open this up in a new tab, and I'm going to zoom in a little bit here. Okay. If you're not familiar with this line of books, this is I guess a kid's book series. In English, this is Where's Waldo, but I think it's French originally, and it might be different in different names, but that's Waldo. So this is what I would see as I'm driving to work, is something like this. And if you pay close attention, what you'll see is Waldo showing up there. And so my question for you is, where was Waldo? Because Waldo, unfortunately, is no longer there. No, it's just like the cardboard has kind of fallen off. So the little like enclave, I don't know what you'd call that thing, that half bathtub is still there, but the actual image is no longer in it. I'll hold this up for 5 more seconds. Okay, this is a wonderfully uniform distribution across the city. I would like to show you where Waldo was. Waldo, unfortunately, is not there anymore, like I said, but here is a map of Winnipeg. We're kind of over here on Winnipeg right now, and I kind of live way over in this area here in Winnipeg. And so I'm going to zoom in to this spot right here. This is Polo Park. I don't know. This is a big digression here now, but when I think of the mall for me is Polo Park. But the mall for lots of people, I realize much later in life, is like different. Different people think what the mall is when they think of the mall. Anyway, this is where Polo Park is, and there's a very small building between these two streets here. And if we drop our little figure here, whoops. That's where Waldo is right there. I'm going to back up just a little bit, and we can get a better look at Waldo. And so this is still here. The outline of Waldo is still there, but Waldo himself is no longer there anymore. Yeah, yes. The last time I saw Waldo there was maybe 2 months ago. But it's been there for at least a year and a half at this point. If you're taking, oh gosh, I have no idea what the route is anymore. This would be where the 74 used to go. I don't know what the route is. 74 and 78 would go this way. I don't know what the route is now, but you'll have to look out your left-hand window to see that. Yes. Yeah. My commute's about 25 kilometers each way. It's faster than taking the bus. And when I do it every day, it's comparable to driving. It's comparable to driving. Like I'm not that fast. I'm not biking 60 kilometers an hour. My average speed gets close to 30, but I'm also not having to stop a lot because I can take bike routes almost the whole way here. Yeah. I don't commute in the winter that way, for the record. Once it gets to be frozen, I can't anymore. Yeah.
How long is that bike ride?
It depends. On a good day with a good tailwind with my road bike, the fastest I've made it home from here is 44 minutes. On average, it's about 50 minutes though, maybe 50 to 55, and then some days it's longer with headwinds and stuff. It can be up to an hour, 5 minutes sort of thing. Yeah. But I don't have to do any exercise outside of that. Yes, yeah. All right, this is a major digression. Thank you all for learning more about my personal life. So I'm gonna give you some time to ask questions here. I do want to just quickly pop up a Learn while we're looking at this to take a quick look at the project overview. And I'm not timing the 10 minutes here while I'm doing this, but I just wanted to quickly remind everyone about the assessment policy and the way that resubmission works and the mastery learning stuff that we're doing. So for each of the different parts of the project, we're kind of identifying that you have to receive a certain level of on the rubric to demonstrate mastery of the learning outcome that we're assessing for the project. Part of this means that we want to allow you to make resubmissions if you haven't met that mastery level. But to be clear, you're allowed to resubmit whether you have or not. If you've met mastery for everything and you just want to resubmit it to get a little bit more points, you're welcome to do that. But please keep in mind the turnaround time for response that we have from the graders is approximately 2 weeks. The other thing I want to remind you about is with regard to the due dates. You're going to have to submit phase 1 for the project. The very kind of like pushing it to the end deadline here is the week of November 10th to the 14th for phase 1. That's reading week. That's the fall term break. But that's pushing it very far. It's possible at that point that if you're submitting it there, you will not be allowed to submit phase 3 for the project. So please keep in mind that we do have to be able to respond to the feedback. We do have to be able to have some time to respond to the submission that you're making in terms of the feedback that you're receiving. I'm going to start my 10 minutes now, and I will let you ask your question first because you're asking. Okay, well, still, if it's about the grading, that's related to the project. So yeah, please go ahead. Yeah.
Like, say phase 1 needs to be resubmitted if you didn't meet the mastery, but
Yeah.
you already started working on phase 2.
Yep.
How would that work?
So that's a great question. The question is, just for the record, for the recording, if you submit phase 1, you keep working on phase 2, which is a good strategy. I'm really strongly advocating for you doing that. But you get feedback for phase 1 that says that you haven't met mastery. At that point, what I'd recommend that you do is to download the submission that you made for phase 1 from UMLearn, make the changes that the grader is suggesting that you make to that, and then I'm going to use the word backport to describe this, but take the changes that you've made for your resubmission and then apply that to what you're currently doing in phase 2. If you are using version control for your project, a really good strategy for this is to basically take your current project and make a branch that represents what phase 1 is, so that you kind of have the state of what phase 1 is around all the time. And then you can continue working on your main branch for phase 2. If you needed to make changes to phase 1, then you have the option to merge it back into the main branch for that. Yeah. So thank you for raising that point. If it's been more than 2 weeks, please tell me, because I am trying to keep track of what the graders are doing, but things, unfortunately, on my end, kind of fall through the cracks sometimes. So please advocate for yourself, and please tell me that you haven't received feedback in more than 2 weeks so that I can figure out what's going on and get on top of that. Okay. Yes, please send me an email. If you're finding that to be the case, please send me an email for sure. Please do it as soon as you can. Okay. Okay. All right. How am I? Oh, do you have a question? Yes.
Yeah, I was just wondering about I heard somewhere, I don't remember where from, but I heard somewhere that when we go to submit maybe phase 2, if we're allowed to submit phase 2, that could like automatically apply to like the revision of our phase 1 grade. I heard that somewhere.
No. Each of the phases are going to be kind of graded in isolation.
Yeah, so if we want any grade 1 to be like reassessed, we need to individually upload our phase 1 again.
Yeah, so if you want phase 1 to be reassessed, you need to resubmit for phase 1. The graders, they are also people and they don't have a ton of time to kind of go back and retroactively apply changes for phase 2 to phase 1's feedback. Yeah. Okay. How am I? I am doing okay. Like I said, I wish that the long weekend was about six days longer, but I'm doing okay. So this is fair. This is actually, I think, kind of related to like something we talked about in the first day of classes, which was imposter syndrome. One of the things that I would say is that the design philosophies that we were thinking about very early in the course, this was KISS, keep it simple, keep it sweet and simple, and Yagni, you ain't gonna need it. I would kind of say like doing less is probably better for phase one. And a general strategy and a general like life advice here in terms of software development is you don't have to fix stuff you didn't make in the first place if it's broken. You can't have something be broken if you didn't do it in the first place. And so having a little bit less for phase one is maybe not the worst possible thing. I'd kind of say also like make sure that you're just focusing on what is there. Make sure that you're submitting something that represents the minimal implementation that you need for something like this. Okay, so very briefly, I'm not going to dwell on this for very long. I was up and out at a hockey arena until almost 10 o'clock last night because my son wants to play hockey. And I don't know if you can tell this about me, but I am a massive nerd and I was never a sports person. For me, sports was playing 5-pin bowling for about 25 years. I got really good at it. I was invited to like invite-only leagues in the city. I do not play bowling anymore. I still don't know anything about hockey, but I'm going to be spending lots of time in arenas for the next 5 years or whatever. If you meet mastery but resubmit anyways, can you also submit phase 2 during the turnaround? Yes, absolutely. The way that we're going to set up the folder for phase 2 submissions is that it's only going to be available if you meet the mastery thresholds for the feedback that you get for phase 1. So if you meet that mastery thresholds, then you are just okay to submit. You can submit phase 2, and then you can resubmit phase 1 as part of that, yes. What are the little monsters from the course homepage from? Oh gosh. This is showing my age because you were probably all not born when these memes were popular. These are Domokun. I don't even know what it is. It's some Japanese thing, yes. That's right. Your grade for phase 1, the only thing that is required is that you meet that mastery level. Anything else after that does not apply to phase 2 at all. So that's a good question. The question is basically if I submit something for phase 1, I get mastery, but I then make changes to phase 1 and resubmit it, but I also submit phase 2 without the changes that I made to phase 1. The rubrics for phase 2 in some cases are going to have things from phase 1. They're not going to necessarily be mastery requirements anymore, but for example, we're going to ask you to continue to do design by contract in phase 2. And so if your changes are related to design by contract, then I would just urge you to put them into that. But yeah, so to answer your specific question, no, not really, but yeah. The course is majorly the project and quiz. How will the finals format look? I mean, we haven't prepared the final yet. However, what I'd say is that the final will look a lot like, the quizzes all stitched together into one long document. That's a good way to think about what the final exam is going to look like and in terms of the kinds of things that you can expect to see on the final exam. If your feedback is very vague, then I would ask you to email me. And this applies generally if you have any questions or concerns about the feedback that you've received, let me know. Because I am able to look at some of the feedback that the graders give you and I ask them to make changes based on what I've read, but I can't unfortunately read everybody's feedback. Also, I'm not grading your projects, somebody else is grading them. So I don't know necessarily what they saw when they gave something. And I want to make sure that the feedback that they give to you is not vague. So please let me know if you have any questions or concerns so that I can ask the graders themselves to let me know what's going on. Phase 2 talks about the happy path. The happy path is this idea of your person using your software, basically using it in exactly the way that you expect them to without doing any kind of invalid inputs. What we're talking about this week and next week is dealing with invalid inputs and exceptions and how to present this information to the person that's using our software. So what we're trying to deal with now is where we're deviating from the happy path. So where we're starting to input invalid things. Happy path very generally is just like enter exactly the correct information, go from start to end in the task that you're working on and accomplish that task and be done with it, but never go outside of that thing. When there are methods in the logic layer that simply pass the argument to the domain model object to modify query it, removing gear by index should the business layer, business logic layer here. So business logic is a common way to describe the thing that we're calling the logic layer of responsibility. So just to clarify that point, should the logic layer validate it or should the domain model object? So we're actually going to talk about that this week and next week. So I'm going to say for now, just have a little bit of patience and we'll touch this in the next few classes. Would you recommend learning version control to manage our phases? I would really strongly advocate for you to learn version control just in general. If you're planning to go into co-op, for example, you knowing version control before you show up in that interview is going to help give you some credibility as you're showing up into the interview. On the course webpage, I have linked to in the content section, in the course resources and then supplementary here, this link, Introduction to Tools and Techniques in Computer Science. This is the textbook that we are using for Comp 1002 and 1006. Some of you I know have taken this course before, but if you haven't taken this course before, what I have tried to do, this is a textbook that I wrote, is that I've tried to do things like introducing you to version control from the ground up as though you have no experience from this. Going up to the point of doing branches and stuff. So the stuff that I was talking about a little bit earlier in class. If you take Comp 1002, you get credit for it. I know you have to pay for the course, but you also get credit for doing this stuff. You don't have to be in first year to take Comp 1002. The ship has sailed in terms of registering for it this term, but next year, when you're starting to your 3000 level classes, this is something that you can also sign up for. All right. So, like I said, I wanted to make sure that I'm not just spending a ton of time up here today talking about this. If I was not able to get to your question, please post it on the course discussion forum, and I'd be very happy to answer it there. But I do want to move on to start taking a look at some other stuff. And so the way that I want to start with this is I'm going to come back to this Mentimeter very quickly in just a second. What I want to start with here is this idea of idioms. Does everybody know, just quickly, do you know what an idiom is? Okay. An idiom is in spoken language and in languages that we use to communicate with each other. An idiom is this thing where we have a specific phrase in spoken languages that has a specific meaning to it, but if you translate it literally to a different language, it doesn't make any sense. It doesn't actually have the same meaning that you've got. I'm going to give you two examples of this, one in English and one in French. The one in English is represented by this image here. And the phrase that we have in English for when it is raining very heavily outside is that we will say things like, it's raining cats and dogs outside. But if I were to translate that into French or Tagalog or any other kind of language, it would kind of literally mean like cats and dogs are falling from the sky. In French, another way to describe this is il pleut des clous, which is meaning it's raining nails. And I kind of have a sense of what that means in English, but like literally raining nails would be like nails are falling from the sky. This is a really common place to have idioms is with regard to raining and heavy rain and different conditions of rain. And so a question that I have for you here is, tell us what an idiom is that's common in a language that you know, whether it be English or not, and tell us what that means in English. Piece of cake, yeah, it's easy. That's a pretty common idiom in English. So hungry I can eat a horse. I'm really hungry. Fry an egg on the sidewalk. Easy like a flat pancake. Break a leg. Put a heart on my sleeve. To pull the donkey out of dirt. Okay, that's not something I've ever heard before. Packed like sardines. Oh gosh, hot like 3 apples? Hot is high, yes? Yeah, so high like 3 apples, okay. Slamming an axe into your own leg, got up on the wrong side of the bed, grumpy, eating my words. Put the fries in the bag, bro, okay. Off to the glue factory, oh gosh, okay. Putting your horse before your cart, when the lobster whistles on a mountain. Okay, that's interesting, equivalent to when the pigs fly. Kill 2 birds with 1 stone, once in a blue moon, 2 drops of water. Even monkeys fall from trees. You're hard-headed, okay. How would a monkey know the taste of ginger? And then Rick Astley, okay, yes. All right, awesome. Okay, so thank you for sharing these. I'm not really thinking too much about idioms in spoken language here, but rather I want to think about idioms in terms of how different programming languages do errors differently. Different programming languages do errors differently based upon the kinds of structures that they have available to them. When I'm thinking about errors here, what I'm really trying to think about is how different programming languages are communicating exceptional states to the code itself or to the programmer. And these are communicated in different ways across different languages. For us in this course, there are 2 different categories that I want us to be thinking about to represent the ways that these errors can be communicated to about or communicated in the language that we're working with. The first is return values in global state. This is something that we as primarily Java programmers are probably not too used to in terms of how errors work and exceptional state in our code works. But we can do this in Java if we want to. The other is exceptions, and this is what we are more used to in Java. Just quick show of hands, try catch. Yes, thumbs up, awesome. Okay, so everybody's seen the words try catch before. We've all dealt with exceptions before, but other programming languages use return values and global state. Each of these different approaches have different trade-offs. So return values and global states, they give the responsibility of verifying that you are not in an exceptional state to the person that's writing the code. So what I mean by that is when I return to you, so literally with a return statement that says something went wrong here, it's your responsibility and my responsibility to look at what was actually returned from this function or method to make a decision about whether or not I should proceed. I have to make that call. I have to check it, and then I have to do something with that. That kind of means that sometimes it's really easy to not check the return value of something and ignore it and then just proceed, and most of the time it seems to work and sometimes it doesn't. That's not necessarily a good thing, but it's fast. When I don't have to worry about exceptions, I don't have to do things like, and I'm going to use this word, and I don't care too much if you know what I mean by this, but I don't have to do things like unwind the call stack because there's an exception. I don't have to worry about any of that stuff. It's your job to check. You have the conditional statement or you don't. That's the error handling mechanism that we've got here. That can be really good when we're in a circumstance where we've got things like, I'm working with a microcontroller and this must be fast. I cannot have this be slow because my processor is running at 8 megahertz and not 5 gigahertz that we've got in our laptops. Exceptions take that responsibility and it forces you to handle these errors. When you were working with files in Comp 1020, you had to write try catch. There was no option to not write try catch. Your code would not compile if you did not write try catch, and try to actually have something in the catch block that says there was an error that happened. That is a good thing because now that responsibility has effectively been forced upon you and you must handle this case. But they're kind of slow. When you have these exceptions, now you have to do things like there may be cases where you're arbitrarily returning from many different functions all at the same time. Your programming language has the responsibility of keeping track of a lot of state for you to be able to deal with this stuff. But they're slow relatively. When we're working with languages like Java and when we're working with languages like Python, whatever, it doesn't actually matter for most cases. My mom is not going to notice and my dad is not going to notice if my code is microseconds slower than it was. They're slow relatively, and that's maybe a bad thing. I want to take a look at some examples, and I want to take a look at some examples in different programming languages. The first example that I want to take a look at is in the C programming language. We'll take a look at an example in Go, and we're going to take a look at an example in Python. I'm going to pop over to my terminal here, and I've already got this Git repository cloned on my local directory. What I want to do with the C program is I'm actually going to take the time to write this up. The Go and Python programs I've already got. I just want to take a look at what these look like. But I want to give you a sense of the kind of things that you need to worry about when you're starting to think about a programming language like C. Again, very strong emphasis. I'm not expecting you to learn C for this course. The things that I'm doing here, you should be able to kind of like squint at this and say, yeah, I totally get what's happening here. But I don't expect you to understand or know about things like pointers. I don't care about that. That's not the important part of this conversation. So I'm going to change directory into the C folder, and I'm going to open up a file that's called hellofiles.c. So in a C program, the very first things that we need to do is similar to what we're doing in Java, where we have to bring some libraries in so that we can start working with them. I want to do some file I/O, and I want to have some access to a standard library. So I'm going to do number include stdio.h and number include stdlib.h. These are similar to import. These are very similar to import in Java. I want to declare my main method. So that's int main void. This looks pretty similar to what we do with public static void main string args, but it's a little bit different. What I want to be able to do is I want to open a file and I want to read the contents of that file. So the first thing I need to do is I need to declare a character array to represent the line that I've read from the file. So I'm going to make a constant here. I'm going to use something called a preprocessor directive to say that my max line length is 100, and that's going to be the same size of the array that I'm making of characters here. Then what I need to do is I need to open the file. This is pretty similar to what you've done in Java, where you're doing like new file or paths.get. But what I'm working with in C is functions. I need to work with a function to be able to get access to a file. The function that I need to use for this is, oh gosh, sorry. The function that I need to use for this is called fopen. Fopen is a function that takes few inscrutable looking arguments. The first thing is going to be the name of the file that you want to pass to it. And the second thing is this thing that's called a mode. The mode here really just means I want to be able to read or write this file. That's all I want to be able to say with this. What it returns to us is this thing that is a file pointer. A file pointer is something that, in terms of what we need to know about here, is something that can be null or not null. That's what we need to know about for this conversation. When I do fopen, I'm going to say something like this. File f is equal to fopen. I'm going to say that I want to open a file that's called readme.md, and I want to open it for read. So I'm going to pass the string r there to say I'm opening this, and I want to only do read operation on this. fopen and in C, the way that we communicate that there is an error that has happened at runtime is that the return value of fopen changes. So I'm going to add a line here that says printf. The value of f is, and I'm going to say %p. This is for pointer. Did you do system.out.printf in Java? So, okay, so some of you are nodding. This % notation is what you've already seen before. We do have to put new lines in here. I'm going to put f there, and I'm going to say return exit success. I'm going to quit out of this manual page. I'm going to change to this directory, week 7-8, lecture 18. I'm going to go to 2450, and I'm going to make this. And I'm going to change into my C directory here, and I'm going to run this hello files program. When I run this right now, there is no file in this directory that's called readme.md. If I list the contents of this directory, the only things that are here right now are hellofiles.c, the program that I'm writing, and then hello files, the name of the compiled program that I've got. So the way that this error is communicated to us happens by return value. Null means that the file does not exist. And not null means that the file does exist. So I'm going to change to my parent directory here where there is a file that's called readme.md, and I'm going to run c hello files, and I get an address, I get a pointer here. Don't worry about it. Don't worry about it. All I'm saying is that I'm getting something that's not null. That's the important part here. This thing that I've gotten back from this is not null now because there is a file that's called readme.md in this directory. That means that it is my responsibility to do things like check to see if f is not equal to null. It's safe for me to actually use this file. In Java, we would get a file not found exception. We would get an exception from this that gets raised, and we would be forced to handle it. It's now my responsibility to actually check to see what the value was returned from fopen. If I don't check it, I'm going to comment this out. If I don't check it and I just start reading stuff into this file, from this file, bad stuff happens. Bad stuff happens. I'm going to say while fgetS. FgetS is kind of like next line with scanner. It's just getting one single line of input from this file. I have to pass the array that I want to write into. I have to pass the maximum number of characters I want it to read. And I have to pass in the file pointer that was returned. And then I'm going to say printf %s new line, just %s and then line. So I want to print out the contents of the file as we're iterating over the lines in this thing. I'm going to make this one more time. I'm going to run c hello files. And when I run this here, it will print out the contents of readme.md. So I'm reading one line at a time, and it's printing everything out. When I change into the C directory and I run hello files here again, we get this inscrutable and like impossible to figure out what it means error message. To be clear, this one error message, when I teach operating systems at the 3000 level, this is something that we touch on throughout the course. This one single line is like 5 different topics, and it's going to touch different parts of our operating system. For us, all we need to know is that sigsegv bad thing has happened, and that my parents would not understand what any of that means. They can't understand what that means. It's our responsibility to check that return value. But one of the other things that we get from this is if I take a look at fopen here, and I'm going to zoom in on this manual page, the other thing that happens with this is that there's a global value that's called errno that is set when there is a problem. So two things are happening here. fopen tells us, communicates to us that there was an error by returning null. The other thing that happens is we have to figure out what that problem was by inspecting this errno value. That's a global value that we can use in the context of our program. I'm not going to look at that right now because it's irrelevant. I don't need to know about C. All I'm saying here is that when I do this in this programming language, by returning the value that says an error has happened, it's my responsibility to have a conditional statement that checks to see whether or not an error has happened. I must have this conditional statement that checks to see if that value is null before I do any kind of interaction like this. That means that I can start running code in this block even though I got an error about 5 lines before this. That's fast, but it forces the responsibility on us as software developers and programmers to deal with that sort of thing. I'm going to quit out of this. I will share a copy of this with you up on the repository. It's actually already up there. It's not exactly the same as what we did, but it's close enough. Go is a programming language that does actually a little bit of both. Go is a programming language where they have formalized, when they designed this programming language, they formalized the idea that we're going to have return values for errors, but in our standard library, in the functions that we're working with, we're going to explicitly say that the error is a separate thing that gets returned. And that means that in a lot of cases, Go functions will have 2 return values as opposed to just 1. The first thing that gets returned from a Go function like read file is going to be the thing that we actually wanted to get, and the second that are being provided by these functions. One of them communicates success or failure, this error value, and the other one is the thing that we actually asked for. If this error is null, so if it's not populated, then we have received an error as part of this operation, and we kind of want to stop. Go has a feature that's called panicking and recovering. Panic is sort of exception, kind of, sort of. It's a very early return, and it just says bail out, basically. There's something that's gone wrong. I can't figure out what to do, so I'm going to stop. But it's still our responsibility to check that this has actually something to us. So right now, I'm going to the other side here. I'm going to change into my run hello file. This is our happy path where we've got this file that's named readme. This is our happy path where we've got this file that's named readme.md. If I change into the Go directory and run that again, the panic gives us more information. This is actually something that my parents probably could figure out eventually if they knew how to use a terminal, but a bit about what's gone wrong, and it tells us a little bit about where things have gone wrong. But I want to emphasize that this, if I comment this out, and I try to compile this again, it gives me an error because I have not used this value that I said I was going to use. And I'm going to replace this with underscore. Underscore in Go says return value is. I'm going to build this again, and I'm going to run it. Here, there was no error message. Things succeeded. It did not crash, but we were able to proceed past that point. With this specific function, the return value that we got from this and the other functions that we're working with, like string, either the contents of this file that we got back was not null, it might be an empty string, or alternatively, the string function itself allows you to pass nil to it and just prints out the empty string for us. But we were able to proceed past this error point. So in a language like Go, it's still explicitly our response. So in a language like Go, it's still explicitly our responsibility to check to see that there was an error, putting that into these functions and saying that these are two separate things. The thing you want to get back. Yeah.
Even though like the feedback is still executing, like if we were to add an element, like the feedback is still executing, like if we were to add an element, the end of it would put a blank line.